Alright, so today we want to move on to logarithmic functions, taking the derivative of logarithmic functions. These ones are not that hard, okay? They're not that complicated like the quotient rule or the product rule or whatever it was, okay? They're not that complicated, but there is an aspect of this that people will often mess up in the execution, alright? So I want to really focus on that. Alright, so we have here the derivative of a logarithmic function. Okay, it's ln of x. Notice again we have a base of e. Alright, we need to have a base of e. If we don't, we're going to change it to a base of e using our change of base formula. Okay, but pretty much everything we use is already base of e. It's pretty easy. If it's just ln of x, the derivative is 1 over x. If, however, you're taking the ln of a function, we have to use, not the quotient rule, the chain rule. Yeah, we have a function inside our logarithmic function, so we have to use the chain rule. Now, here's the deal, okay? Just to derive what we have here for the derivative, it says it's f prime over f, okay? The derivative of ln of something is 1 over that something, right? We just saw that. Derivative of x is 1 over x. So the outer function here is the logarithm. And the derivative is 1 over whatever you're taking the logarithm of, 1 over the argument. But then with the chain rule, you have to then multiply by the derivative of the inner function. So here's where the f prime comes in. This is where people mess up. They'll put the times f prime of x in the denominator as well. And it's not. Okay? It's 1 over f of x times f of x, and if you want, over 1. That's how it becomes f prime of x over f of x. Really easy mistake to make. Okay? It's a really easy mistake to make. So, let's see this in action a few times here, practicing. Okay? So here we have the derivative of ln of 1 minus 3x. Okay? So, dy dx. The derivative of the ln of something is 1 over that something. But then I have to multiply by the derivative of the inside, which is negative 3. So this is negative 3 over 1 minus 3x.
So the ln doesn't play a part in this?
Well, it does in the fact that we get 1 over. That's where the 1 over thing comes from. Okay, but we will not have an ln in our final answer. Okay?
Mm-hmm.
So that's not too bad, right?
No. Not yet.
Not yet. You're so optimistic. All right. Let's try this one here. Okay? What are we going to need to use here? X cubed times ln of x.
The 1 over.
First the chain rule. No.
Product rule. Okay? Product rule. U is x cubed, right?
3x squared times.
So good. That derivative is 3x squared. V prime, if V is the ln of x.
1 over x.
There we go. Yeah. Okay? So there's our 1 over x. So now dy dx is u prime times v plus u times v prime. Okay? Now here's where some simplifying will come in.
But wouldn't the derivative be 1 over x times x? That's the
No, it'd be 1 over x times the derivative of x, which is 1. Okay?
Mhm.
So simplifying here, this is x squared. And if you think about, whoop, not plus there, hang on. With an extra plus sign. Okay. Should be times. Okay? If you think in terms of like terms or factoring, there is an x squared here. So I have x squared times 3 ln of x plus 1. I'm not necessarily going to require that at this point, but it may be nice to get into the habit because later on, as we look to find when the derivative equals 0, to find that you're going to want to factor. So maybe worth the practice now. Okay? That's your final answer.
Too many words.
Okay? Alright, let's try some other ones here, okay? Now, there are cases where we can use properties of logarithms to make finding the derivative easier, okay? Remember here, when we have ln of a product, you can change that, you can expand that into the natural log of one factor plus the natural log of the other factor. Okay, so for example, if I have ln of x times e to the negative x, I can rewrite this as ln of x plus ln of e to the negative x. Alright? That's using this rule down here. Okay?
If there's a coefficient in front of the natural log, could you add like 3 ln x plus 2 ln x? Is that 5 ln x?
3 ln x plus 2 ln x would be 5 ln x. Yeah, as long as the arguments inside the ln are exactly the same.
Okay.
You can't add those. Now, the second rule there you see is if we have a quotient, you can write that as the natural log of the numerator minus the natural log of the denominator. Okay? So for example, if I am looking at this second example here, I could rewrite y as the ln of x squared minus the ln of...
Wouldn't it be 2? You'd also have to do the first one as well.
Well, actually, we can then use the first rule as well. Yeah, just using this subtraction, first of all, we could split this quotient up into 2 ln's like this. Okay? Then, this is what Carly was just saying, I could actually then use the first rule again. Okay? Just be careful with the minus that you keep this all in parentheses. But ln of x squared minus ln of x plus 2 plus ln of x minus 3. Okay? So you'll notice we're able to manipulate these things so that what's inside the logarithm is actually very simple. Okay? Any questions so far with how we're simplifying these? Okay? Now watch this. We have here another rule, and that is the ln of something to a power, we can pull that exponent out as the coefficient of the natural log. So in this first example, I could rewrite y as ln of x plus, I could make that a negative x times the ln of e. Why would I want to do that? What does ln of e equal? 1. Alright? So this is just 1. So now I'm taking the derivative of ln of x minus x. Okay? Well, what's the derivative of ln of x?
1 over x.
And what's the derivative of minus x?
Negative 1.
Minus 1. So it's 1 over x minus 1. Okay? Now you might say, well, do we have to do this? Do we have to use the rule? Let me show you what happens if we don't. Okay? If I don't do this, if I don't use these rules, I'll do this in brown. Okay? I would have to use what? What would I have to use? The product rule inside the chain rule, and then inside the product rule I'd have to use the chain rule again, actually. Okay? Watch this. Watch this. dy dx, the outer function is ln of something, right?
Right.
So I have 1 over that something. Okay? But then I have to multiply by the derivative of that something. Now the derivative of that something is going to take the product rule, right? So I have u prime, which is 1 times e to the negative x, plus u times v prime. What's the derivative of e to the negative x?
E to the negative x times negative 1.
Yeah, e to the negative x times the negative 1, so we'll put that in there. Okay? And I know that looks simple because we just wrote down the whole answer, but we may have to write out a few steps to get there. Okay? So then if I would distribute this to both parts here, notice what happens. I've got, let's use purple. Okay? This e to the negative x is going to cancel out both of those, right? And that's going to leave me with 1 over x minus x over x, which is 1 over x minus 1.
Of course.
Yeah, you got to be real careful because we're doing the chain rule and then the product rule inside the chain rule and then the chain rule inside the product rule inside the chain rule. Okay? So there's a lot that you have to be careful about, and this is where knowing these laws can make life a whole lot simpler for you. I'm not going to bother doing the one on the right, because you can imagine what we've got with that. We've got the chain rule, and inside the chain rule we've got the quotient rule, and inside the quotient rule with that denominator we've got the product rule. Okay? And that all is a real pain in the butt. It's going to take a lot of work to get all that worked out. If instead we'd use what we're doing here, okay, notice I could actually pull out this 2 ln of x minus ln of x plus 2. I'm going to distribute the negative minus ln of x minus 3. Now I'm just taking the derivative of each of those parts. Okay? So, dy dx is, what's the derivative of 2 ln of x?
Oh, it's 2 over.
2 over x, there you go. 2 times 1 over x, so 2 over x. Remember, constant multiple, just take the derivative of ln of x, multiply it by the constant. Okay? Now, minus, what's the derivative of ln of x plus 2?
1 over x
1 over x plus
plus 2.
2. What's the derivative of x plus 2?
1.
It's just 1. Alright, so that's kind of nice. And then how about we have a minus the derivative of ln of x minus 3. What's our derivative there?
1 over x minus 3.
Very good, 1 over x minus 3. And the derivative of x minus 3 is 1 again, so that's it. That's a whole lot easier than doing the chain and product and quotient rule all in one.
But if on the bottom of like, for example, 1 over x plus 2, it will be like 1 over x squared plus 2, then you will need to take the chain rule of that, so like include 2 to the x on the denominator.
Yeah, you'd put 2x on the numerator there. Yeah. If that were an x squared plus 2. That's correct. Okay? So, these rules, you know, it may have seemed a little silly last year when we were in pre-cal honors and back when you were in algebra 2 honors and you were expanding and condensing these logarithmic expressions. This is why. This is one reason why. It makes these a whole lot easier. Okay? Alright, so all we have left to do at this point is do some practice. Okay? Just take some practice. So we've got our IP. Go ahead and I want you guys to take some time to work together on the IP. Okay? I really do want you working together because you will help each other catch those little mistakes that you're making lots of on the quizzes and stuff. Alright? You guys make these little arithmetic errors or algebra mistakes. Work together so you catch each other's mistakes. Okay? And if you finish all of the IP, you can start reviewing with those worksheets as well. Okay? Alright.